Hello, and thanks for clicking on this next Narculus production. Today we're going to be talking about using the product rule. Okay, how do we derive f of x times g of x? So we haven't worked with it yet. We've done f of x plus g of x. We've done f of x minus g of x. But we haven't looked at two expressions in terms of x that are being multiplied. All right, so let's take a look at how we would derive f of x times g of x. Now, unfortunately, it's not as simple as you would hope it would be, right? Your hope would be the fact that you could just derive each one separately like you could for addition and subtraction. That is unfortunately not the case. All right, so we're going to use this limit definition of the derivative. We already know this, right? The limit as h goes to 0 of f of x plus h minus f of x over h. That's equal to f prime of x. Okay, so what we're going to try to do is we're going to try to derive f of x times g of x. So the derivative of f of x times g of x must be the limit as h goes to 0 of f of x plus h, g of x plus h, minus f of x times g of x all over h. Okay, we're just applying this definition, this concept, to the fact that these two are being multiplied by each other. All right, now we want to calculate this limit. Now this limit is much more complicated than it looks. What we need to do is we need to actually throw in a term or a couple terms here in the numerator that's going to help us to calculate this limit. Now, so let's just rewrite the first part of it. And what we're going to do is we're going to throw in a very, very, very fancy 0. We're going to throw this term in by adding it and subtracting it. Now, you might be saying, how would somebody know to be able to take negative f of x times g of x plus h, positive f of x times g of x plus h, and throw it in here? It seems like the most random thing you'd ever throw in, and you'd be right. But the good news is the folks who founded calculus back in the day, they had a lot of free time. They didn't have the internet. They didn't have anything like that. So, they didn't have social media. So they had a lot of time on their hands. So they were able to figure this stuff out. All right, so now what we're going to do is we're going to try to calculate this limit. We're going to do, let's take a look here. So let's take a look at the numerator. We're just going to look at the first two terms only, just these two terms. Now, if you look at them specifically, you see that there's a GCF now. G of x plus h is in common. So I'm going to take that and I'm going to factor it out. So I'm going to take out g of x plus h, and then that will leave me with inside f of x plus h minus f of x, and I'm going to stick the over h there. Okay, so that looks semi-familiar. And then over here, with these two terms, I see that f of x is in common. So I'm going to factor out f of x. So I'm going to take out an f of x there. And then inside, I'd be left with g of x plus h minus g of x. And again, all over h, because now these two terms are added. Right? These two terms are now added, so this denominator is actually getting split up. Okay? It's got to go to both of them. Well, that worked out very conveniently for obvious reasons. And now, the limit laws allow me to take this limit, and basically I can so-called distribute it to all of these. So if I come down here, I guess, we'll have the limit as h approaches 0 of g of x plus h times the limit as h goes to 0 of f of x, f of x plus h minus f of x all over h, looks familiar, plus the limit as h goes to 0 of f of x times the limit as h goes to 0 of g of x plus h minus g of x all over h. So now let's see if we can evaluate each one of these limits. Well, the limit as h goes to 0 of g of x plus h just means take 0 and put it in for h, and you would get g of x times the limit as h goes to 0 of f of x plus h minus f of x over h. Well, that's the derivative of f. That's the limit definition of the derivative. This whole thing makes the limit definition of the derivative. This is f prime of x. There it is. Plus the limit as h goes to 0 of f of x. There's no h in that at all, so that's just f of x. Times the limit as h goes to 0 of g of x plus h minus g of x over h. That's the limit definition again, except with g. So that would be g prime of x. And this is the product rule. G times f prime plus f times g prime. So to formalize it for you here, the product rule, the derivative of f of x times g of x. To derive it, you leave the first, multiply by the derivative of the second, plus leave the second, multiply by the derivative of the first. Leave the first, derive the second, plus leave the second, derive the first. Okay, so it is definitely more complicated than adding and subtracting. All right, so let's try to find, here's my function, f of x. It's x cubed times sine x. I want to find the derivative of that. So first thing you should notice is that it's some function in terms of x, x cubed, times another function in terms of x, sine x. So to do this, we're going to have to use the product rule. All right, so the derivative, f prime, would be, leave the x cubed, we're going to have to derive sine x, plus leave sine x, and then we're going to have to derive x cubed. Leave the first, derive the second, plus leave the second, derive the first. Okay, so f prime, we got x cubed. The derivative of sine x, that's cosine x. Leave the sine x. The derivative of x cubed is 3x squared. And there's my derivative. Okay, now there is a GCF, right? You can see it. X squared is in common. It could be factored out. Could be working with a multiple choice question or something where x squared is factored out. It would leave me with x cosine x plus 3 sine x. That's also a possibility for an answer. Either one of these is good. And that's how you apply the product rule. Leave the first in terms of x, derive the second, plus leave the second, derive the first. Okay? All right. Let's try to write the equation of the tangent line to this function h, x cosine x, at x equals pi over 6. Okay, so to find h prime, again, this is something with an x times something else with an x. So we're going to leave the first, derive the second, plus leave the second, derive the first. So h prime, leave the first, the derivative of cosine x is minus sine x, plus leave cosine x, the derivative of x is 1. And now I want to write the equation of the tangent line to h at x equals pi over 6. So I need two things. I need to know h prime of pi over 6. That's going to be my slope. And then I need a point, right? I need a point and a slope. So the point will be at pi over 6 comma something. Let's do that first. We'll do the point first. So let's find h of pi over 6. So that's going to be pi over 6 times cosine pi over 6. That's pi over 6 times cosine of pi over 6 is root 3 over 2. So that's pi root 3 over 12. That's my point. And then to find the slope, I'm going to have to take pi over 6 and plug it in for x in the derivative. So that's going to be negative pi over 6 times sine pi over 6 plus cosine pi over 6. So negative pi over 6, sine of pi over 6 is a half. Cosine pi over 6 root 3 over 2. So that gives me negative pi over 12 plus root 3 over 2. Okay. You can find a common denominator if you want. You don't have to. Negative pi over 12 plus root 3 over 2. And then my equation of the line is going to be y minus, in point slope form, pi root 3 over 12 times, and now I'm going to put the slope in parentheses. I really need it there because I'm going to have another set of parentheses in a minute. That's going to have x minus pi over 6 in it. And I want to make sure that somebody knows you have to multiply this whole thing by the x minus pi over 6. If you leave off the parentheses, you can see it would be root 3 over 2 only times the parentheses there. That's not what you want. This is my equation of the tangent line. And that's the correct answer. Okay? And that's it. That's all there is to the product rule. If you have something with an x, term with an x, times another term with an x, you leave the first, derive the second, plus leave the second, derive the first. Okay? And as always, thanks for clicking.